All right, you are starting a topic on measurement. There is one assignment. You've been hammered with tests. There is one assignment on this. It's an 8-page directed investigation. It is a good example of what I like to call a fluffy assignment, which is not like what you would experience in general or essential maths. There's a lot of research to it, but the maths is easy. It's like multiplication, subtraction, etc. So you need to experience that style of assignment. The style of assignments that you do in methods and spec, they're more along the lines of that projectile motion thing that we did at the start, but over an extended period of time. So just a reminder for the people that have joined us now, anything in blue is what I think is formulae, is examples, is what I think should go into your cheat sheet and in your book. The black is just for me to help teach you. So what is surface area? The surface area of a solid with planar faces is what we're doing today. The surface area of any 3D object is the total area in square units of everything on the outside. Okay? An object that's got planar faces is one where all the sides are flat. So all we're dealing with today is a shape that's 3D, but every side is flat, no curves. The formula for the surface area of such an object is this. So the surface area of any object with planar faces is the sum of the area of all the faces. Sum means what? Add, subtract, times, good. So get that formula down. The surface area of objects with planar faces is the sum of the area of all the faces. And then I'll go to the assumptions on the next board. So that's your formula. Nothing special there. It just tells you to add, yeah?
Can I have a pen right out?
While I'm recording, don't say anyone's names. It'll piss me off if it happens in the middle. And I have to edit it. Don't do that. If I do it myself, then I'll piss off myself. All right. Clearly, that formula that I just gave you makes the assumption that you know how to find the area of all different kinds of shape. I'm not going to be like some other people that might say you should know these. I don't like to do that. I don't know whether you know them, so I'm going to teach you from scratch. Okay? So if you don't know the area formulae for different shapes, here they are now, but let's work through it together. What would I need to know to find the area of that shape?
Two different sides.
Good. So the longer one we'll tend to call the length, and the shorter one we'll tend to call the width. So the area of a square or a rectangle is going to be length times by width. What's special about a square? They're the same. Good. Someone else. Triangle. What do I need to know to be able to find the area of a triangle? I know you know he wants to say it so bad, yeah?
2 thirds.
What, this and this?
Oh wait, yeah. Wait.
Be more specific.
2 sides that aren't the longest, not the hypotenuse, right?
Two sides that aren't. No.
Yeah,
Okay, the memory's vague, that's why we're doing this, yes?
Half of length times height.
Oh, basically excellent, yes. But we call it the base instead. The bottom side that forms the base of the triangle, and we also need to know how tall the triangle is. Is this how tall the triangle is, that diagonal line? No, that's leaning. The height of something is how tall it is vertically. So what he said, the area is half times by the base times by height. What do you notice about the relationship between the height and the base? What's the angle between those two lines? Right angle. What's the word for that? You just did it in your test. It starts with a P. Perpendicular. So just be wary. H and B are perpendicular. Right, can you get the triangle and the rectangle formulae, please? You'll be hammering these. Anyone know off the top of their head what the area of a circle is? Excellent. So what do I need to know about this circle? The radius. I need to know how long it is from the middle to the edge, which is the radius. Do you know what the line is called that goes all the way across? Diameter. Well done. So if I know the diameter, what could I do to the diameter to find the radius?
You could probably half it.
You could probably half it indeed. So the area is pi times by the radius squared. Now, some people, especially in my general maths class, they take that too literally and they go pi times by the radius and they square the whole thing. But we're at night here and we know bed maths. So what does the square apply to? Does it apply to the pi?
No.
No, it's only applying to the radius. So you find the radius, you times it by itself, and then you times the answer by pi. Okay? This one's tricky. I don't find that a lot of people know how you find the area of a parallelogram. Notice that it's a rectangle that someone's pushed over slightly. Any ideas? How do I find the area of a parallelogram? Technically yes, but we call it the base. The base times by the height is not that. The height is at right angles to it. So the height is straight up and down. Okay? So the area of a parallelogram is base times by height. Height and the base are perpendicular to each other. Last one, trapezium. You have a quadrilateral, it's got 4 sides and 4 corners, but one of the sides is shorter than the other and they're parallel to each other. Does anyone know what the formula for finding that is? You don't need to, I don't expect you to. What if I drew a line here that is directly between that point there and that point there, which is in line with the bottom here? So I draw a line vertically like that. And then can you see if I draw a point over here, if I draw a vertical line directly in the middle of those two as well, what shape do I have in red here? Square or rectangle? What do you notice about this triangle that exists? Does that fill in that triangle because it's directly halfway? Yeah. That triangle that exists, does that fill in that space there? The area of a trapezium is, how do I find the average of two numbers? I add them together and divide by 2. So the area of a trapezium is side A plus side B divided by 2, the average of the short and the long side, which is what I drew here, times by, how do I find the area of a rectangle? You times it by the width. So times it by the height in this case, up and down. So A plus B over 2 times by height. Those are the only formula that you'll need. Can you please get that down? I'm going to turn this board around to do an example together, which is not, it looks easier than it probably is. If I can work it out. If you've got those formula down, please, can you have a think about how we would find the surface area of this? Just checking that it's on the camera. We've got sort of a rectangular prism on the bottom, and there's a square-based pyramid at the top. Six times?
8 times 4.
Excellent. I like his thinking there. So how many of these rectangles are on the outside? There's 4 of them. So I don't care how you set up your working, but try not to just set an answer at the end. Because if you get the answer wrong and there's no working, can I give you credit for anything? No, you're just wrong. So you're 0. So maybe what I'll do is I'll put like a bracket around here and show my working there. So you've got, I'll draw a little label, the rectangles. 8 times by 6 equals, what's that, 48? 48 square centimeters. How many of those rectangles are around? 4 times 48 is 160, what, 182? 182 square centimeters. So we've dealt with
192.
192, my bad. 192 square centimeters, we'll deal with that. What shape is on the bottom of that? A square. So we'll do a little. What's the area of that square?
6 square centimeters.
6 times 6 is going to be 36 square centimeters. So I'm going to underline the things that I need to add together. Is the pyramid as easy as... No. Because how tall... Is that triangle... Look, Mr. C, it says 4 centimeters. Is that how tall that triangle is?
No.
Is that triangle wonky?
Yes.
So we need to think a little harder. You remember a little guy, a Greek guy, I think it was Greek, I don't know. Pythagoras? Is there a right angle triangle that goes from the tip there down into the middle?
Yes.
And if I got that right angle triangle and went down to the edge here, would the hypotenuse of that right angle triangle be the height of my wonky triangle?
Yes.
How long is the short side of that right angle triangle? It sits across
3 centimeters.
3. How tall?
4.
Do we 4? So it's a 3, 4, 5. Let's do Pythagoras up here. You have a right angle triangle. It's 3, 4. So hypotenuse squared, C, squared is equal to 3 squared plus 4 squared. 9 plus 16 is equal to 25. So C is going to be?
5.
Do I know how tall the triangles are now?
Yeah.
So this line here, now it's blue, is 5. What's the formula that your classmate gave for the area of a triangle? Area is, so triangle, area is 1/2 times by the base. How wide is the base of our little wonky triangle? 6 times by, how tall did we just determine the wonky triangle? 5. 6 times 5, 30 times by 1/2, 15 square centimeters. How many of these triangles are there? 4. There's 4 going around. So 4 times by 15 equals 60 square centimeters. Mr. T, do I need to find the square at the bottom of the pyramid?
No.
Because the surface area is the external sides. Are the squares on the bottom of the pyramid and the top of this external? They're inside, they're not exposed. So that's not part of the surface area. So what numbers do I need to add? Total SA equals 60 plus 192 plus 36. 6 and 2, 8, 9, 10, 11, 12, 18, 2. 288 square centimeters in total. Let me just check that because I might have to edit.
That sounds about right. Yeah, no, that's right.
Yeah, because I remember I stopped. I'll stop the recording now. Can you get that example down, please?